Exponent. So you could also read this as exponent of an exponent. Okay? So this is going to be a little bit different because it doesn't say product. So we're not going to be multiplying here. We're going to be taking an exponent and we're going to be raising it to another exponent. So this is different. Okay? It doesn't say product of a power. It says power of a power. So we're going to start with example 8. We've got 3 examples that go behind this door. We're going to start with example 8. Example 8, in parentheses, you have an x, y to the third, and you're raising that parentheses to the power 4. So if we did this problem the long way, which you can, but you're not going to want to do it the long way, don't write this down, but just think with me for a minute. The long way would be what? What would the long way be? It'd be x, y to the third times itself. How many times? 4 times. Y'all with me? We don't want to do this. Okay, so you're not writing this part down. I'm just showing you. That would be the long way. Because that says x, y to the third raised to the 4th power. So that would be x, y to the third times itself 4 times. So we don't want to do that. Okay? So that's why we have an exponent rule for this. So what's the exponent on your x?
3. Oh,
1. 1. Okay, so the power on the x is 1 and the power on the y is 3. So we have a rule that says when you raise a power to a power, you multiply those powers together. So when you raise 1 to the 4th power, you say 1 times 4. And 1 times 4 is 4. So that's going to give you the new power on your x. Okay? When you do a power raised to another power, the rule says you multiply those powers together. So let's look at our y. The power on our y is 3. And we're raising 3 to the 4th power. So a power to a power, you're going to multiply those. And 3 times 4 is 12. So the new power on your y is 12. And let's talk about why that answer makes sense. So if we look at the long way, why does the x to the 4th make sense? If we look at the long way, x times x times x times x is really x to the 4th. And y cubed times y cubed times y cubed times y cubed, you would really say 3 plus 3 plus 3 plus 3, and that's going to give you 12. So it's just a shortcut. We don't want to do everything the long way because you don't have time for that. We have to have simplistic rules that make things easier for us. So when we have a power raised to another power, we're going to multiply those powers together. Let's look at another example, example 9. All right, let's throw in a coefficient here. Negative 2 would be considered our coefficient. We have an x squared and a y to the third on the inside of our parentheses, and then on the outside we have a power of 2. Okay? Now, again, I'm just going to write the long way. I don't want you to do it the long way, but I want you to see what we're really doing here, and then I'm going to show you the shortcut. So that really says we're doing 2x to the second y to the third times itself how many times? Twice. So that's the long way, but we don't want to do it the long way. We want to do it the short way. So what you have to do is you have to start with your coefficient. This coefficient is not a power. So you actually have to do base to the exponent just like we reviewed yesterday. So what is a negative 2 times itself 2 times? A positive 4. Okay? That's not a power to a power. That is a base to an exponent. So you got to do that. You got to do that differently. That's a base to an exponent. That's 4. Now you're going to do power to a power. So take your x first. The power of x is 2, and you're raising it to another power of 2. So 2 times 2 is 4. So you're going to have x to the 4th. Go to your y. Your y is a power of 3. It's raised to another power of 2. Power times power. 3 times 2 is 6. Okay? Your coefficient is your base, and you're raising it to the second power. You'll have to do that differently, but the x squared and the y cubed, you're just going to multiply power times the power on those. Power times the power. Does that answer make sense if we go back and think about the long way? Would a -2 times a -2 be a +4? Yes. Would x squared times x squared be x to the 4th? Yes, because 2 plus 2 is 4. Would y to the 3rd times y to the 3rd be y to the 6th? Yes, because 3 plus 3 is 6. Okay, if we have to go back and think about the long way or do it the long way, you can, but they're not wanting you to do it the long way. They're wanting you to do it the short way. All right, so here's one that gets really difficult. Last example underneath this door is example 10. Example 10. All right, so this is for the big boys. This is where we kind of throw everything in together here. So this is kind of 2 problems in one, okay? It's kind of 2 problems in one. Y'all remember the little phrase, please excuse my dear Aunt Sally? Okay, what does the P stand for? Parentheses. Do you see any parentheses in this problem? Okay, so we're supposed to do what's inside the parentheses. So inside the first parentheses is 4AB. So there's really nothing to do inside that parentheses. There's nothing to add, subtract, multiply, or divide. So there's really nothing to do inside these parentheses. These parentheses are here just to show you that you are multiplying. Okay? So it says please, and then it says excuse. What does the excuse stand for? Exponents. When it says excuse, it's talking about the 2 and the 4. It's talking about those 2 exponents. So that's what you have to do first. You have to take 4AB and raise it to the 2nd power. So what is 4 squared? 16. Okay, you got to be careful. 4 is not a power, it's a coefficient. It's a big number. So you've actually got to do 4 to the 2nd. 4 is the base, 2 is the exponent. Then you're going to take your A and your B, which have understood exponents of 1, and you're going to do the power to the power rule, which says you're going to multiply. So 1 times 2 is 2, so I have A to the 2, and then I'm going to do 1 times 2 again for the B, and I'm going to have B to the 2nd. Now I'm going to stick that term in parentheses because I'm not finished. I've got to go to the next parentheses and raise it to the 4th power. So that's going to give me A to the 12th, and it's going to give me B to the 4th. All right, before I go any further, is there anybody that has a question about that step? So again, we're following our little please excuse my dear Aunt Sally. We're following those order of operations. We do that 99.9% of the time in all math classes that we take. Those are just our rules for our operations. So we've done parentheses, okay? We've done the exponents. The next thing is to multiply. And that's what the parentheses are really telling you. Hey, we're multiplying here, okay? So it's going to be 16 times what? 16 times an understood 1 is 16. Then you're going to multiply your A's together. Remind me what that rule is. If we're multiplying, what do we do with the powers? We add them. So 2 plus 12 is 14. And then go to your next variable, B to the 2nd times B to the 4th. Add the exponents, B to the 6th. All right, so that was a little extra difficult problem because we had to do power to a power first, and then we had to use our product rule where we multiplied by adding the exponents. So that problem was a little bit more difficult. Any questions? All right, we're almost finished with our notes. Open up the next door, which is power of a product. Power of a product. We have one example that we're going to put under here. Power of a product. All right, underneath power of a product, we only have one example. That's going to be example 11. And we've kind of already done this one, but we're going to put it behind this door just in case you might have a question later on. This, you could go back and just look behind this door and see an example for it. So really in example 10 we did this. Okay, we did one very similar to this. But let's talk about why it says power of a product. Where's the product in this problem? Y'all see anything that would represent a product?
2 times x.
2 times x squared times y to the 5th. All that stuff in parentheses is really a product because it's all being multiplied together. So we're going to take that product and we're going to raise it to the 4th power. So this is just showing you when you have several things that are multiplied together and they're all in a parentheses, all that stuff is in parentheses, it's been multiplied together as your product and it's being raised to that power. Okay? Now I'm going to go ahead and tell you most people will make a mistake with the 2. The first 2, the big 2, because they're going to forget that it's not a power. Okay? It's a base. This first 2 is a base. So when you raise 2 to the 4th, you do that differently. Okay? 2 to the 4th means what? 2 times itself 4 times. It doesn't mean 2 times 4. It means 2 times itself 4 times. So what is 2 times itself 4 times? 16. All right? Then you can use your power to a power rule because on the x you are raising a power to a power. So then you're going to do 2 times 4 is 8 and have x to the 8th, and then you're going to do 5 times 4 is 20 and you're going to have y to the 20th. But the 2, the big 2, is not a power, it is a base. So you have to raise that base to the 4th power. All right, questions about example 11? Last set of notes for today are going to be behind the door that says a to the 0 equals 1. These are our last notes that we're going to take today. So behind the door, a to the 0 equals 1. We have 2 examples. Example 12. This may be something that you already know. Do you know that anything raised to the 0 power is always equal to the number 1? Anything. Any number, any variable raised to the 0 power is always equal to the number 1. That doesn't make a lot of sense, but it's just a rule in mathematics, just to be honest with you. Okay, I can teach you something in the next set of notes that we're going to take the next time that we're together. It's going to kind of back this rule up, but you don't know that yet, so you just have to kind of step out on faith and believe me on this. Anything raised to the power of 0 is equal to 1. Anything, even something that has a whole bunch of variables in it. So if you made it really, really difficult and you had a big long product like 2 times x times y cubed times z to the 5th and you had all that in parentheses and it was raised to the 0 power and you're thinking, oh, this is going to be a horrible problem, it's going to take me forever. No, it's not, because anything raised to the 0 power is always equal to 1. Anything. Any number, any variable, any product, anything raised to the 0 power is equal to 1. All right, those are the end of our notes today.